All right, so Monday's assignment is going to be factoring review, and we are going to be factoring quadratic equations. Almost every single, I think there's one that's like that 7x4 plus 9x. That's why I have that up there. That's the only one that's not quadratic. All the other ones are going to be quadratic. So I wanted to do just a little bit of review, and there's a couple of different things you have to look at when you first look at a problem to factor it. First of all, is it 2 terms or 3 terms? If it's 2 terms, you have to think either greatest common factor or difference of perfect squares. That's your only option, okay? So if it's greatest common factor, well, I guess I should say if it's not a difference of perfect squares, you're going to for sure do greatest common factor. So when it looks like this one right here, let me kind of blow that up a little bit. There we go. 2 is not a perfect square, okay? This x right here is not a perfect square. So that eliminates difference of perfect squares. So what you do is you look and see what is the greatest common factor. And between 2x squared and 4x, they both have a 2x in them, okay? Remember, when you're doing greatest common factor, anytime you're factoring, it doesn't go away, it goes out front. So that 2x would go out front. And then what's left is, well, the 2's cancel out. One of the x's cancels one of them out, leaving behind 1. -4 divided by 2 is -2, and the x's cancel out. So that's what it would be. That's your answer factored. Okay? So if there's 2 terms and they're both not, everything's not perfect, then you're just going to factor out the greatest common factor. With this one right here, okay, similar idea. 7 is not perfect. So you can't do different, and it's not a difference problem, so it cannot be difference of perfect squares. So since there's 2 terms, think greatest common factor. They both just have an x in common. The x doesn't go away, it goes out front. And then what's left is a 7, and then this 1x cancels out one of the ones on top, so you're left with 3 on top. And then the plus 9 is left, and the x's cancel each other out, so that's what you're left with, and that's the factored form. So remember, factoring is just pulling it apart into pieces. So when it looks like this right here, okay, first of all, k squared is perfect because k times k gives you k squared. It's a difference problem, and 100 is perfect because 10 times 10. So this meets all the qualifications to be a difference of perfect squares. And when that's the case, your answer is going to be 2 binomials. The k squared is k and k. The 100 is 10 and 10, right? Because 10 times 10 is 100. And then you put 1 plus and 1 minus, and it doesn't matter which order you do it in. And that is that factored. Difference of perfect squares are super easy to factor. This one right here is another example of a difference of perfect squares. Because 25 is perfect, it's 5 times 5, right? 5 times 5. The x squared is perfect because it's x times x. And the 16 is perfect because it's 4 times 4. And since it's a difference problem, it meets all the requirements to be a difference of perfect squares. So your answer is one of each. And each, remember, your answer is going to be 2 binomials. And you're going to have 5x and 5x because that gives you the 25x squared. And then you've got 4 and 4. And then with difference of perfect squares, it's always 1 plus and 1 minus. If you guys don't put this in your notes and then you don't know how to do the work, then I'm not going to feel sorry for you. So make sure you're getting these written down in your notes. I'm giving you an example of everything you're going to see on Monday without me here. All right, so the last thing we want to look at is when there's 3 terms. Okay, you have to work it different when it's 3 terms. You still always want to think greatest common factor because if you can factor out something in common, it just gives you lower numbers to work with. Okay, so if we look at this one as an example right here, we're going to do this one. The first thing we want to do is look and see, does 18, 192, and 270 all have something in common? Well, they're all even, so you know they all have a 2 in common, but think higher than that just in case there's more. So the factors of 18 are 2 and 9 and 3 and 6, right? So we know they're all divisible by 2, but let's try 9. So the way you would do that is you would take Obviously, 18 divided by 9, that's 2, so that works out. Try dividing 192 by 9 and see what you get. And when you do that, you get a decimal. So it's not divisible by 9. So then you go to 3 and 6. So if you know that 18 is divisible by 6, try dividing 192 divisible by 6, and that comes out as 32, so that works. And then 270 divided by 6 also comes out even, and you get, fingers aren't working today, you get 45. So that means that we can factor a 6 out of all these. And what that's going to do is it's going to give us lower numbers to work with. So we pull the 6 out front, and when we do that, we divide every one of these numbers by 6 to give us lower numbers. So we would have 3n squared plus, what did I say that was? 192 divided by 6, 32. 32n, whoops. And then 270 divided by 6 was 45. So plus 45. Now what we've done is we've given ourselves much, much smaller numbers to work with. So now we go to our factor sum table, which if you look at your notes, you go greatest common factor first, then you do factor sum table, okay? And you have to do the factor sum table when you have 3 terms. So first times last, so 3 times 45 is 135. And your sum is always that center number, so 32. Okay? So I'm going to, for right now, that 6 doesn't go away because when we factor, it doesn't go away. It just goes in a different place. So I'm going to drop that 6 down here, and I'm going to eventually put it in my final answer. So I don't want to forget it. I just want to forget it for a minute. Okay? So just looking at what's inside the parentheses, we know that 1 times 135 works, but that adds up to 136, so that's not going to work. 135 isn't even, so 2 isn't going to work. 3 times 45 is 135. We know that because that's our little arch that gave us that to begin with, but that adds up to 48. You can try 135 divided by 4, but it doesn't come out even, which means it's not what? Doesn't work. So 135 divided by 5 is 27, and lo and behold, whoops, that adds up to 32. So there's your winning factors. When you find your winning factors, they have to replace 32n. So that means you've got 3n squared. Which one should I put first, the 5 or the 27? Yeah, plus 27n plus 5n, and then plus 45. I split my 32 into 27 and 5. Now I factor by grouping. Divide both of these by 3n because they're both divisible by that. Again, right, it doesn't go away. It goes out front, the 3n, and I'm left with n plus 9. And then here I factor out a plus 5. Goes out front, and I'm left with an n plus 9, which is what I wanted. So I take my 3n and my plus 5, and they make up my first binomial. And then my matching n plus 9 makes up my second binomial. And then the last thing I have to remember is I got to remember to stick that 6 out in front because it is part of the factors. And that's that one factored. So that's what you're going to have on your, now remember just real quick, if there is just a 1 out front, two and 3 would be plus 5. So if I do this, I need factors that add up to 6 or multiply to 6 and give me 5. I get 2 and 3. Remember when there is a 1 out front, okay, this is an easy one. Why is it easy? Go right from your winning factors to your x plus 2, x plus 3. You can go right to your answer. You don't have to do all that factor by grouping stuff in the middle. Okay? And that's it. And if you took notes, then a couple of your homework assignments for Monday are already done for you because they were done here in this video. So for those of you at home, go ahead and click on load. It's a 2-page assignment. Do front and back or page 1, page 2. And it is all factoring review. And email me if you have any questions.